Jump, jump.
Hello everyone, welcome to this new class, and this will be focusing on prototyping tools. Okay, so what are prototyping tools? Prototyping tools are like tools you use to make prototypes of your electronics before actually building them real time. So the prototyping tools we're going to look at here is one, the Arduino Uno board, which we talked about in the last video. So in this video, this will be about prototyping tools. Prototyping tools here are Arduino Uno, the breadboard small. I'm going to drag that from the components area, and then jumper wires. Okay, so this is your prototyping tools. The Arduino, it's a really complicated board, not so complicated, but it's really powerful with what it can do. The Arduino board has digital pins at the top, which starts from pin 0 and ends at pin 13. If you put your mouse on these pins, you'll be seeing D with the number like D11, D12, D13, D9, and the rest of them. So because these are also digital pins, that's why the D is in front of them. All right, so here is this rectangular box here is called the microcontroller or the microprocessor. This is a very small microprocessor that can process a little bit of data. It helps the Arduino to process the code you send to it. So this is the brains of the Arduino itself. Here is the analog pins starting from A0 and ending at A5. So the analog pins taking analog input pins. So the analog pins are a lot more sophisticated pins because they can take a range of data. They take data from 0 to 1023. And the digital pins here take data which are just 0 and 1. Okay? Note the difference. The analog pins taking data which are 0 to 1023 because analog data can be huge. When you're taking in data from a sensor, you have to look at so many varieties or variations. But the digital pins only take two data. That's why it's digital, 0 and 1. Digital pins also have something called PWM, which stands for pulse width modulation. Okay, what this simply does is that it makes the pins, this particular digital pins, much more advanced. If you look at some pins on the digital pin module, like pin 11, 10, 9, 6, 5, and 3, they have a little tilde at the front of it. So this tilde is actually for PWM modulation. Okay, so these 5 pins you see, 6 pins, you see on the Arduino are for pulse width modulation. So it makes your digital pin more advanced. You can actually use this for a radio control to reduce the volume or increase the volume because it has a variation of digital outputs or digital inputs. It can read data from 0 to 225. These PWM pins can be amplified, so you can amplify them. Saying, for instance, you have a volume and you want to reduce the level of volume or increase the volume. This is where these pins come into play. Or if you want to work with an LED, you just don't want to use 2 values. You want to use a digital pin that has so many values to make an LED, to reduce the brightness of an LED or increase the brightness of an LED. This is where the PWM pin comes from. PWM just helps to control the amount of intensity on a digital pin. Don't worry about that. You'll be working with some projects using the PWM pins. Okay, so here you see the power pin. These power pin are responsible for delivering power to our project and also to the Arduino. The first one you see here is called the VIN. So the VIN can give your Arduino extra power. So for instance, you don't want to use the USB or the auxiliary power cord, you can just connect a wire from a battery and put it inside this VIN and then put it inside the GND. It's going to power up your Arduino. So the next is GND. GND stands for ground. You find that there are 3 GNDs on the Arduino, 1, 2, and 3 at the top of digital pin 13. So GND are for ground. Ground pin just helps you complete the circuit. Okay, so not advanced thing, it's just completing the circuit. Here is the 5V pin. So the 5V delivers 5 volts power to your project. So if you're working with a sensor or a component that needs power, that needs a much more higher power, like 5 volts, you can actually tap 5 volt power from there, because Arduino has an operational voltage of 5 volts. So 5 volts can be easily delivered to your project. So next is the 3.3V. 3.3V stands for 3.3 volts. So this can deliver 3.3 volts power supply to your project. So for instance, you are working with some components that don't have advanced usage or advanced power plugs. You can just use the small power plugs for them, which are like 3.3 volts. Okay, so the next is reset and IOF. So this is a reference, and the rest is the reset to reset your. The reset is just to reset your Arduino. Okay, so here you see a jack. So that jack is called the power jack. It's an auxiliary power jack where you can plug in your auxiliary power cord. After you've uploaded your code into the Arduino, you can remove the USB and put the power jack. We'll be using that here, but that's what it's supposed to do. And here is called the USB port. So the USB port, that's where all our codes get sent from. So you have to connect a USB cable. It's for you to connect a USB cable, and then the code is being transferred from the computer to the Arduino. So now this is the reset button. So this reset button, when you press the reset button, it will automatically restart your code from the top. So your code just keep running from the top to bottom. So probably if you have a problem and you need to debug, you just need to press the reset button and then try to see where the error is coming from. Alright, that's for the Arduino. There are some few components you need to point out, but we won't do everything for now. Alright, so just a quick tip, this on button here, or this on icon, will tell you that okay, the Arduino has been powered on. So whenever you see the button, whenever you see the LED on, that means the Arduino has been turned on. So at the top here, you see 0 and 1 at the top. This is for RX and TX. So RX and TX simply stands for receiving and transmitting. So the RX and TX pin are for transmitting and receiving data. And you will notice sometimes when we're uploading our code, the RX and TX LED will start blinking. That means there's a transfer of data from the computer to the Arduino. Okay, that's for the basic components for the Arduino, and the basic one you need to know. There are some other things like the capacitors, the clock, and some other things, but those are not really relevant. But you can still know them. Well, because the clock is for you to calculate the speed of your processing, and then all the remaining power plugs, just like the capacitors, the resistors, the MOSFETs, are for power control. So it helps control the power on the Arduino. So this is the breadboard, and what I'm dragging out of the breadboard is called a jumper wire. So to drag a jumper wire, you have to click inside an empty hole on the breadboard and you drag a jumper wire. And then by clicking on the jumper wire on any spot, it will break the jumper wire. So you can click and you can break it to any dimension you want to break it to. So I'm going to show you how the breadboard is connected. So if you see on the breadboard, this is the breadboard small. At the top and bottom part, you see there's a plus rail, which is the red line, which symbolizes positive, and then the top is the negative rail, which symbolizes negative connections. So if you see the connection, how it's connected, the plus rail is connected horizontally within a straight line. So the plus rail is connected horizontally, and the negative rail is also connected horizontally. Whatever if you put your wire here on your plus rail, and then you put another wire at the last end of the plus rail, it will all be connected because it's connected on a straight line, which is horizontally. And at the top is a different connection, Whenever you put a wire here and then you put another wire beside it, it's going to be connected because your connection is made on a straight line. You need to get this really well because we're using a breadboard a lot, so you need to know the way to connect or the way to use your breadboard. So these plus and minus rails at the top and at the bottom parts. The bottom part is also the same thing, but the minus comes first. So the minus rail, this is where it's easy for you to connect power to. So you can put all your negative or your ground pins on the minus rail, and you can put all your plus pins on the positive rail to give power and give ground to your Arduino. We'll be working with those things in a short while, but just note that this is the longest connection on the breadboard. It starts here and then it ends here. Same things with the plus. So now we'll come over to the middle side of the breadboard. So this is labeled from A to E and from F to J. So A to E is connected in a column and is connected vertically. It has different connections from 1 to 30. It has different connections from 1 to 30, and these connections are connected 5 in a column. So these are the columns. Whenever wire you plug here, you can see it's everything just light up green. That means this entire row are all connected. I'm going to zoom in a little. So number 2, that's the second column, is going to be connected. Whenever you plug a wire here, you can actually tap from that same connection at the last end because this entire row is connected. So same thing goes from 1 to 30. Okay, so they are all different connections, but it's the same at that particular column. So they have 5 holes in that column. So each of these 5 holes are the same, but they are different from 1 to 30. Anytime you put your components in one of these holes or one of these columns, be very careful not to attach it to the next column because it might give you error or your program might not work. Okay, so same thing for the top, F to J. So F to J is a different set of connections connecting from 1 to 30, and then this F to J are still the same thing as the A to E. There are 5 holes in a column, so these are connected vertically and they have different connections from 1 to 30. Congratulations, you have come to the end of this class. I hope you learned a lot. You've created a lot of exciting topics. So see you in the next project. Don't forget to watch, learn, and practice.